All right, so we're going to talk a little bit about light, light and its wave-like nature. Light has what's called dual nature. It behaves like a particle and a wave. And so this is one of the strange things about light and the universe. But all waves, including light waves or sound waves, shock waves, can undergo interference. They can constructively interfere. This basically means you have waves in phase adding up. So the troughs line up and the peaks line up, and that will give you a big wave, okay, a bigger wave. That's what's happening when you have very good surf conditions, okay? All your waves are adding up, constructively interfering. The opposite of that's called destructive interference, and your waves will basically cancel out. So a peak and a trough will line up, and that will end up giving you zero. If your waves, or initial waves, have the same intensity, they're just offset, okay? Another property of waves, and so light in this experiment, which is a slit experiment, you're shining light through a narrow opening, a narrow aperture. It will undergo diffraction patterns. We're not going to talk a lot about this, but physics classes, if you take an introductory physics class, you'll go over this. And basically the light waves are changing directions as they go through that narrow slit. And light does this. Again, other waves do this, all waves do this. And so this is just another experiment that shows you that light is indeed a wave, but it's also a particle, okay? Because of the photoelectric effect, classical physicists were treating light as just a wave when they were thinking about how the photoelectric effect would work, okay? So here's just a little review problem. Which of the following statements is correct? The energy of a 450 nanometer photon is greater than the energy of a 587 nanometer photon. That we can think about that. That indeed is correct, okay? Why? Well, 450 nanometers, that's a lower wavelength than 587 nanometers. That means a higher frequency, and a higher frequency means more energy, okay? The other two statements are not true. The speed of light will vary depending on the wavelength of light. No. The speed of light is always constant in a vacuum at 3 times 10 to the 8th meters per second. An electron will be ejected from a metal surface if you focus a high-intensity laser beam on the surface. That's also not true. It depends upon the wavelength of the light, right? It needs to have more energy or equal energy to the work function of the metal. And if you just take a really high intensity, a really bright laser beam, but of low energy light, like a radio wave or something like that, you won't get any electrons ejected. So that's the photoelectric effect in essence. All right. So in next video, we'll talk about the last confounding experiment that led to the creation of the theory of quantum mechanics, and that is the hydrogen line experiment. So we will see you then.